I recently reviewed the Neolock IC tester that's intended for dynamic and static RAM of vintage types that are not usually produced anymore but are quite common on vintage computers. And it also tests PIAs and VIAs and so on. Along with that, I wanted to acquire a general Logic IC tester. I didn't have one in my shop. And after a lot of looking around, I decided on a particular one by RSR Electronics, which does business online as Electronix, spelled with an X, Express. And here's their website. It's www.elexp.com. And the particular model I'm looking at here is found by going to test equipment and then going way down here to the bottom and going to specialty equipment, I believe, and there's IC and battery testers and the several different models. They have one for linear ICs, and they sell the BK Precision one that's much more expensive. And this RSR linear IC tester, quite a large one, also about $3,000. And then the least expensive one is this Vizatek, spelled with a V-I-Z, portable digital IC tester. The manufacturer's part number is listed as 01 VZ-4, although on the actual product it just says VZ-4. I believe that the 01 VZ-4 is Electronix Express's or RS Electronics' in-house number, and it shows their stock number is the same thing. It's $225, and although it's not specifically listed here, they do sell a wall wart power supply for it, because you can power it from wall wart or from internal 9-volt battery. So now that I've established where the product comes from, and by the way, I believe this is an exclusive. I haven't seen anybody else selling this particular model of tester. Amazon does sell it at about, I think, $50 higher price, but the seller is Electronix Express, so it's coming from the same place. And indeed, when I called Electronix Express, they said that they warranty the item for the usual 90 days, as would be the case if you bought it on Amazon. But after the 90 days, if you bought it from Amazon and they don't have a record of selling you to directly, they said that then they don't offer tech support anymore after that point. Whereas if you buy it from them directly at the lower price, then they have you in their system and they'll provide tech support, I guess, pretty much indefinitely, as long as they're in business. And they will repair the unit if it needs repair, apparently only if you buy it from them directly. So not much reason to buy this on Amazon. I just bought it from Electronix Express / RSR Electronics. So here's the box. It's quite obviously a Chinese produced item, just the low quality cardboard and so on, but that was no surprise. The box comes with exactly this, a manual, which is two 8.5 by 11s folded over and printed on both sides. Obviously could have been printed on smaller paper, but that's the way it's done. And they did not have this for download on their website, but by requesting it from them, they emailed me a copy. But it's got the cover, it's got a brief description of how the keys work, and its general specifications, although they're rather incomplete. Sort of a bit of information on how to use the external 5-volt power supply or wall wart adapter. And they note that it's important that you disconnect the battery when using the adapter. They don't have a switch in there and they interact and can cause bad things to happen. And it has a little diagram showing which way the ICs go in the ZIF socket, or zero insertion force socket. And a little bit about entering the IC numbers. For example, to strip out all the extraneous stuff and If you're doing a DM7400N or a DM74LS00, you just enter the 7400. That's pretty straightforward. Basic instructions on how to test the known IC and to search for an unknown IC or an unmarked IC. And the product also works as a function counter, which is sort of an odd thing to match with an IC tester, but that's what it has. There's a list of all the 7400 series ICs, and it doesn't exactly say, it does say that TTL family ICs, but it says that it'll include LC, HC, ALS, and F. The C's in there, I'm thinking, means CMOS. I believe this will test both the TTL and the CMOS versions of the TTL chips, although it's not really clear here, and I don't use the 7400 series hardly at all. I don't stock them in my shop, so I was unable to easily test that part of it. I just tested it with this 4000 and 4500 series CMOS chips. So there's the 74 list, and then there's the 4000 series and the 4500 series ICs, and that's all she wrote for the manual. Inside the box, there's really nothing there except for the tester, and that's it. I did buy this wall wart from them, and I could have used any other one, but I knew this way at least it would match the barrel connector on the back without having to figure out what that was and hunt it down, so I just bought the one from them. I think it added about $10 to the price, which is not unreasonable. And once again, you have to make sure you don't plug it in at the same time there's a battery in it. So here's the tester front, and it's got an unbacklit LCD display. It's got a 28-pin ZIF socket, and actually it's a 3M one, so it's a quality socket. And it's got a 4x4 membrane type keypad, pretty self-explanatory, and otherwise it's just a big heavy plastic case. It's got an on-off switch on the side, and on mine the label they put on there keeps falling off. It's not a very good label, or it was stuck on plastic that still had release agent on it or something, and that'll probably end up falling off and staying off. But the switch is marked 0 and 1, so you don't really need the label. The other side has nothing except a quality control label. The back has the battery connector, or the battery compartment rather. 9-volt battery. The back has a hook that you can hang it on the wall. I'm not sure what these little things on the side are. And it also has a kickstand, which has basically two positions, all the way up or all the way down. And if you put it on the kickstand, it holds at a reasonable angle for use. I do find that if you use it without the kickstand and you're pushing buttons, you can see from the side that there's a big unsupported area on the back. So if you're actually pushing the buttons, just activation force tips it up and down like this, and that's not too great. I may put some little rubber feet on this or something so it doesn't do that. Of course, if I just use it with the kickstand out, then there's no issue. On the back is a BNC connector that's just used for the frequency counter function. It's an input. And then the barrel connector for the 5-volt wall wart power supply, should you choose to use it. There doesn't seem to be any marking on the unit itself about not having the battery in it when that's plugged in. I'm probably going to add a label to this on my own to remind me of that, since it's not something I'm going to use all the time. So, taking a look at the keypad, it's just got the 0 through 9 numbers. It's got a button for beginning a test. There's actually 2 of them. As near as I can tell, they do the same thing. Then there's a button to clear it out of whatever mode it's currently in. There's a button Find, which initiates a search of the IC you've got plugged in. in an attempt to figure out what it is. And this is not perfect, as I've already found out, but at least it's a useful function. I'm not sure any IC tester can be 100% in that regard. And then there's the mode switch, and all that does is switches it between IC testing mode and frequency counter mode. There's really almost nothing to remember on this as far as use. Now, kind of showing some issues here, it may show up in the photo. You can kind of see how the display is scratched up. It came this way from the factory, basically. It had a protective peel-off film on it, and when I peeled that off, I could immediately see that it was scratched. So I've got a RMA going with the seller to get this swapped out with another one. And I also want to point out that on the front of the unit it does say VZ-4, and that's what it also says on the manual. That seems to be the going number, even though, as I pointed out earlier, it's also referred to as 01 VZ-4 without the hyphen or dash. So I'm going to demonstrate this here by just throwing in an IC. I'm going to pretend I don't know what this is. Let's put it in the ZIF socket. I have to lift the lever up first, and then put the... And that's what just happened to me here was the IC falls out. With the angle that this thing goes on its kickstand, the IC pretty much wants to fall out. It's right on the hairy edge. It'll just barely stay there, and the slightest bump will cause it to tip out and fall on the floor of the table. So that's not ideal. And actually you need two hands to do this because otherwise it'll slide down to the bottom. So I put the lever down to tighten up the ZIF socket, and I went a little too far. Let me bump it down a little bit. There, that's more or less centered. And I turn the unit on, and it says Digital Device Tester. I found that the time delays on the display here are very quick. Like, it barely displayed Digital Device Tester before it cleared it. And again, typical of some of these products coming from China, it's not a digital device tester, it's a digital logic IC tester, so even the name that comes up on the display is a bit of a misnomer. Makes it sound like it should test all sorts of other things. Anyway, it asks for the device number. I'm going to pretend that I don't know it here, so I'm going to go down here and push the Find button, and immediately it says device number auto search, and it's not too easy to see on the LCD, but there's a couple, 2 or 3 decimal points that flicker on and off rapidly while it's doing the search, and it can take up to about 30 seconds, I found, to go through all the possibilities until it finds the search. I don't know if it goes through an order and does all the 7400s first and then the 4000 series. Not really sure what algorithm it uses. I'm just sitting here waiting for it to come up with something. It beeps and says device number 4001. Well, I happen to know that it is a 4001 because it says so right on the part, but it also gives me the option of pushing the next button and seeing what else it might have found. Let's see if I can get it clear in the display again. So now it's auto searching some more, and it basically didn't find anything else. So the only thing it found was a 4001. So at this point I just key in 4001. It's there on the display, and then I push the test button, and it's going to happen really fast here. Testing, test passed, and it clears so fast if you blinked you missed it, which I think is a pretty crummy feature of this thing, is it should stay there until maybe you push the clear button or some other button, but having it go away so quickly is a drag. At least the testing doesn't take long, and if you missed it you can do a test again. This time I'm going to use the other button, proving that either of the test buttons work. Now I'm going to release the ZIF socket and take this out, and I'm going to I'm not going to ruin the IC. I'm going to fold one leg of the IC up. Actually, that's a power supply pin. Let's not do that one. Oh wait, no, that isn't. That's a ground pin. I don't want to do that one. So I'm going to fold up the pin next to it. So I've got a pin folded up here, and now it's back in the socket with that pin not making contact. I still have 4001 up here. I'm going to push the test button again. Test failed, as it should have. So that seems to work. I also have a 4503 here. I'm going to test that out. That's a 4500 series CMOS logic IC. So I'm going to clear and push 4503, and I'm going to watch the display carefully, and it passed. Now if I clear this out and tell it to find it, here's an example of what I noted with this on some earlier tests. It's going to search for about the same amount of time as it did before. Give it a little bit longer. Okay, first choice it came up with was a 74367. I know it's not a 74367, so I push next, and it auto searches some more, and now it says a 4503, which is indeed what it is. Now I looked up the 74367 or whatever that was, and the two parts, that and the 4503, are nearly identical, but there is a subtle difference. The 4503 and the other chip are hex buffers with tri-state output, so they have 6 buffers in them with the outputs tri-statable by 1 or more control pins. And there's 2 control pins on here. On the 4503, unless I got it backwards, one of the control pins controls 3 of the buffers, and the other control pin controls the other 3 buffers. So you can operate it as 2 sets of 3 tri-statable buffers. Meanwhile, the other chip, the 7400 series version, looks almost exactly the same, but on the data sheets, the 2 gate or control pins are ANDed together, and then the output of that AND controls all 6 buffers. So subtly different from the 4503, but yet this tester identifies the first choice, and maybe that's only because that's the first one it comes to, if it really does the 7400s first. And apparently its algorithm or data table or index or whatever it uses is not sufficiently detailed to tell the difference between the 2 parts. And for all I know, maybe there is some manufacturer of the 7400 version that makes them just like the 4503 and they programmed accordingly, or maybe they just read the data sheets wrong. I don't know. Anyway, there is a subtle difference between the 2 chips, and this tester doesn't accurately know the difference, so it's not perfect. I've tested it on a bunch of other logic ICs, and it did a pretty good job of finding them. This is the only one I found that misidentified the part, but I didn't check every part in its database either to see which other ones might do it. So, good but not perfect. I'm going to check the frequency counter function out now. Okay, now for the frequency counter mode. I go down here and push the mode button, and it switches to frequency counter mode, and it's displaying 9 Hz, 10 Hz right on the edge. It alternates back and forth. I have my Hewlett-Packard 3312A function generator here, and it's on the 10 range, and it's selected just shy of 1, so right on the hair edge of 1, so it should be 10 Hertz. And I've got the amplitude and offset adjusted, so the low end of the, oh, I should also point out it's on the, let's see, it's on the square wave output. So let me check my scope here and make sure the ground is where I think it is. Well, I had to mess around and rescale the voltage here, but I'm getting 2.5 divisions now on a 2 volt per division setting, so that's 5 volts. And it looks funny because I'm only going at a 10 Hertz signal here. And it's locking on again pretty good at 9 Hertz, 10 Hertz. And the only reason I use the scope is that the manual says that this frequency counter is, well, what does it say? It doesn't say anything about the frequency counter, nothing about what range of voltages it uses or anything. I don't know if it can tolerate voltages higher than 5 volts without damage or without malfunctioning. I don't know if it'll work at less than 5 volts. I can try that and see what it is. But on the high end, I could be doing damage before I realize it. I also don't know if it'll tolerate voltages going below ground, if it has protection for that. I'd like to believe it does. But for the moment I'm being relatively careful with it and not allowing it to go very much below ground. So I do have a request into the seller to see if they can give me better specifications on this so I can make sure I use the instrument correctly. Anyway, so I'm going here and it's accurately reading the frequency. Now if I go up by 1 decade to 100 Hertz, it comes up with 95 Hertz here. I go to the scope, change the sweep, change the position, and it's actually showing just a hair on the high side of 5 divisions at 2 milliseconds per division, so it's pretty close. It's showing the period to be a little bit slow, a little bit longer than 5 divisions, which indicates that the frequency is a little bit lower than 100 Hertz, which is exactly what the counter is saying. Now, if I go here and adjust my frequency on the generator, it's really hard to get it much finer than that. There doesn't seem to be a vernier for adjusting the frequency, so it's real touchy. But I got it up to say 100 Hertz here. And if I go over here now and adjust the position, it's pretty much spot on. So now I go back here and I go up to 1 kilohertz, and right away it's reading 1.000 kilohertz. And once again I verify that with my scope, and it's on. I go up here to 10 kilohertz, and once again it's reading correctly there. Change the sweep, and again it's really close. I can go up to 100K. Shows it a little bit on the high side of the frequency. Once again, the scope agrees. It's showing it just a little bit less than 5 divisions, which would support the slightly higher frequency here. And now I go up to the 1 meg, and it does reflect here the frequency is a little bit on the low side. And this is about as fast as this scope can go. It's only a 20 megahertz scope, so I'm already starting to push its ability. But if I adjust it in here, again, everything seems to be pretty much right on. Beyond that, I don't know what happens if I go higher. I can crank my generator up to an order of magnitude higher, but it is not showing 10 megahertz. I think it's bonking. And my scope won't even really show that very well. So I think that 1 megahertz is probably about it. Let's see if I go down to 5. So it's not correctly showing the frequency here. If I go back down to 1, it's pretty accurate still there, but it does seem to bonk even at 2 megahertz. It seems to be flaking around, it's jumping around. If I go up to 3, it's getting worse. If I go up to 4, it's just not able to do it. So I would say that the specs on this is probably no higher than 1 megahertz if you want it to be accurate. And the display strobes about once every second. You can kind of see it there, so I think it's working on a 1-second clock. Still an odd feature to have on an IC Logic tester, but it might be of use to somebody. So I don't think there's much else to say about this product. It's I would say it's on the high side price-wise. It seems to be reasonably well built. There are other IC testers out there that are substantially cheaper, and I don't know how they compare to this in terms of physical quality and accuracy in testing and breadth of the IC library that's programmed in. I do plan to buy another one that's about $50 instead of $225 and try to do some comparisons, and I'll do another video on that. But for now, that is the Vizatek VZ-4.